Well, hello there everyone. How are you doing today? Let's do a little bit of NPC dialogue programming today. And not even just programming, because we'll quite possibly be doing a little bit of dialogue design. Even some audio recording. So unlike normally, I've actually routed this the game audio to you this time around. So you should hear the engine sound of the car. If I've done it correctly, if you can't hear it, just let me know. And the reason I've done that is, of course, that you should be able to hear some dialogue today when we get to that point. You should also hear some sound effects from the menu. I have put in a few radio sound effects, tied them to this radio menu here. And the radio menu, of course, is how we will actually sort of hook the dialogue into the game. So basically, as we've seen previously, if I load these vehicles here, load test vehicles. Nothing obvious happened, but we actually loaded a few vehicles into the world. So we have one here, for example, and this guy is marked as having the radio enabled. So we can see here that we have a scout on slope is the call sign for this one person here, and that vehicle is the one that's standing there in this slope, and we can give the person or the driver commands, such as move here, for example. Except that it doesn't seem to work currently. Let's see. Okay, now it works. That was strange. And we should get a few more audio cues along with some subtitles and all of that when you're doing these kinds of things. So currently the audio, the sound effects are just hooked up to opening and closing the menu. You might actually have several contacts here. When we select a contact, we want some kind of greeting to take place. This is really actually kind of strange. I wonder if I have some new bug here or something with this menu, because it's not really behaving like I expect, but I guess we'll find out. When we select this person, we can see that, okay, we're now essentially talking to the scout on the slope, and we can give it some commands or some messages. Only one currently available. And we can see down here that the narrator, which is the character that this vehicle is currently set to, the narrator character is sort of like a fallback. If you don't set any specific character to be the driver of a vehicle, it falls to the narrator. And the narrator barks com radio greeting. So communications radio greeting. That is sort of the ID of the bark that we want to play here. And if you don't know what a bark is, it's like a small, self-contained almost piece of dialogue, which can be triggered by the gameplay code in various different scenarios. So in many games, for example, if you have some sort of combat situation, maybe one of your friends can bark something like grenade out, or I don't know, taking cover, reloading, whatever. Those would be barks. I don't really have barks currently for anything in the game, but I actually did a little bit of groundwork on a bark system. And I think this com radio will now be the very first system which will use barks. So I already have some of this stuff wired up to the radio, as you can see. When we say move here, or first of all, when we open the menu and we select the person, they bark com radio greeting, and when we select move here, they bark com radio accept, com radio message accept _ movement. And we'll get into what those mean in a little bit. But basically the idea is that the system should randomly select a suitable thing to say. So this ID basically means that, okay, this is first of all, this is a com radio bark. They accept my message. They can also refuse. If you didn't see my previous stream, we can open this main gate here. Like this, and then we can close it behind us. And now, since the gate is closed, if we now select this guy and we tell them to move here, once the gate is closed, well, we get some debug information here that we can't actually find a path, but the narrator breaks com radio message refuse _ movement. The _ movement is just like a movement specific version of that bark. So so far it kind of works, but we need to somehow hook this up to the system and already play some dialogue here. So if we go to the main menu and we actually load into like the campaign here, we actually do have some systems in place for playing back dialogue. We should see a dialogue in like 2 seconds or something. Right, I can just pause the game here. So we can see here we have a character. This is not the narrator. Now this is a character called Rowan. They say, "All right, Minerva elevator station. It's supposed to be the fastest way onto the plateau." I don't have any audio recorded for this yet, but it does support that as well. And as the mission progresses, you get all kinds of dialogue things triggered. And so we can essentially use the same system as far as the like showing on the HUD and playing back the audio is concerned. We can use the same system. We don't trigger it from these things are triggered from a mission script, and the barks won't be triggered by any kind of script at all. They will be triggered by the new bark system. So for example, if I drive here, I didn't go to the main gate. I went here instead. And Rowan says this gate seems to be closed. Maybe try the main gate. If you did go to the main gate first and then came here, you would get a slightly different piece of dialogue right there. So this thing is sort of already doing what we want. And now we get some dialogue here. Like so. So let's look at how this actually works. Unload the editor for us so that we can make code changes if we want to. That's not actually the window I want. That is probably the window I want. So essentially what we want to happen in the end, the thing that will actually play this for us, happens in the in-game UI view model. This is a message. This is a big switch case reacting to all kinds of messages. On message received. We receive a specific message called mission dialogue. We have a mission path hash, which we actually don't use currently, but then we get some component or some parameters out of this message. Is the text localized? True or false? What the text is. what the audio is. So this is a string, as you can see from this type here. Whoa, let's not break the stuff. This audio string right here is a path to an audio event. We'll look at what that actually means in a second. Character path hash is well, it's the it's the hash of the character path. The character path is essentially a unique string identifying a character in the game. So it knows what to actually show there in the text. And then duration is just in seconds. Typically, if you have an audio clip assigned to this, the mission system will actually figure out the length based on the audio and then put that here. But you can override it if you want it to stay there longer. And then we have a message queue in the HUD, and we quite simply push the dialog line there. And we can see here that it goes essentially into a queue, and then this queue is read from somewhere. Where was it read? Right here. So it basically there are a few different queues. We have a message queue. We also have a dialog queue. We're figuring out if the line is already playing. If it's not, then we call this play internal line dialog, or play dialog line internal. And this is where we're actually doing the showing and playing of these things. So we have a HUD dialog line. So that would be this the subtitle. And then if we have an audio event path, use Timbre Sound Manager, play path, play by path, and forget. The and forget there means that we're quite simply giving it a path to play, and we don't really care about that afterwards. So you can, for example, you can get a handle to an audio event if you want to change the pitch or the volume or whatever as it is playing. But then you need to remember to release the instance, do all kinds of bookkeeping things. In this case, we just want to play this one line. We don't want to care about it afterwards. So I've shown you in previous streams and previous videos my audio system called Timbre. So here we have a few things that I can go through. So these things are supposed to take place over like communications radio. So we have a wave asset here, demo intro Diego 00005. I think I have this open here. If I find the asset, voiceover. These are just some like AI generated audio files, right? Sure looks like something is burning, is what he's saying. And if we pipe it through this radio effect, it looks like this. So there's a little bit of signal processing there, making it sound more like it's coming out of a handheld radio, and there's a little bit of sort of bookending it with an effect at the start and at the end. And if you want to know what this radio effects node looks like, this is the internals of the radio effect node. So it's there's a lot of stuff here, but it's not super complicated. For example, this whole thing here, actually including that node, is just like randomly selecting one of these 4 wave assets to play at the end, and the beginning thing is there. Then we have some filters to apply to the audio. We play it, and we put like a little bit of static on top of it, to make it sound like it's being played back through a radio. And we can apply this to all kinds of things. So something like this perhaps would be pretty nice to use for these barks as well. And of course the most simple of these would just be essentially when you select one of those characters, they would go like, hey, what's up, or something like that, because you're essentially like contacting them over the radio. So let's start working on this. So I did a little bit of preparatory work, added something called a bark manager. Here you can see these bark types. These were the things that we were actually sort of printing out there already. So we have an enum, there's a com radio greeting, and this should select randomly something to play. So we know essentially like, we know the character that is saying something, or the com radio manager rather knows. And then the bark type is like, what are we saying? And this com radio greeting could have like maybe 2 or 3 different lines per character that it randomly selects from. Unfortunately, we can't actually do the random thing here in this in the Timbre audio engine. Like this is, for example, the close com radio menu. I can do this the random branch thing here, and every time you play it, it sounds different. And this is kind of nice, but we can't do it like this, or at least I don't think it's a pretty good idea to do it like this, because when we're talking about voiceovers, we obviously want to match the subtitles to the actual spoken thing. So I think we'll need to select what to play in the code, and then have just a matching piece of audio and subtitle. Then we have like a radio message. Like you can, at least the plan is to be able to send all kinds of radio messages to people. Currently we just have the move here one, but they could be something else. So we have just a very generic, what? Generic is what it's supposed to say. A generic sort of accept and refuse, like affirmative or I can't do that. And then there's like a movement specific one, so like on my way or I can't get there, or whatever we want, whatever we end up using for those things. And there's a bark manager, and this bark manager really doesn't essentially contain anything yet. It's just boilerplate code. So we have essentially like this place here. Play bark. This is where we would actually kick the whole thing off. So we get a character ID. We have all the characters here. The narrator, as mentioned previously, is the sort of default one. But we have the other ones here. And to be able to show the subtitle, we need the character path, which we spoke about previously. And so these are the paths. You might be wondering, why do we have like a path when we just have the character here? Isn't that like enough? This character ID is essentially not really used for anything yet. I actually just added it. So these characters actually come from another one of my tools. We have them here. So this is sort of like a database of things. Their ID here is, for example, narrator, but they can have a first name and a last name and a color. So this color is, for example, that's the color that the name is rendered with in the subtitle line there. And here you can see the path, and you can also copy the path from here and you get it down here as well. So characters, Rowan. But I also added this enum here and just added a comment to make sure that we keep this in sync with the characters in Nemo, and you can get the path like this. That should make it easier for us to actually work with characters, because you can then get auto completion for selecting the correct one and so on. So it should make it a little easier. But if we go back to the bark manager, we have this play bark thing here. If we are on the client, so we're working on a client server environment here, most of these radio communication barks, if not all actually, they will be triggered by the server, because the server is the one that actually sort of carries out well, the work that needs to happen when you send a radio message to someone. So if we play this again, so now we're playing the campaign. These two vehicles here, they have their radio communication set up. It's actually arguably not really necessary. This can skip this intro cinematic currently, but anyway. So if we open this, you can see the campaign mother. So that vehicle over there is the mother vehicle, and we can ask them to move here. So when we ask someone to move to our position, we need to do a bunch of things on the server. We need to figure out, okay, is there like a nav mesh path there? Is the thing that we are actually ordering around even capable of moving potentially? Might be issues there. So the server needs to determine, okay, can we actually carry out this message or not? If we can't, then the server is the one that determines that we can't, and it is the one that determines that, okay, we need to now bark with like a refusal message. Here we say move here. We can see that, okay, they accepted the movement and now they're moving to the position. And let's get out of the way, because we will be completely obliterated by the mother vehicle if we don't. So that kind of stuff. And because of this, we are most of the time actually initiating the bark on the server. So it will essentially go to this else. And this is something that I added just a few hours ago actually. I have this host ID here, which I don't typically, or I don't currently use for anything. I might have to actually hook it in later, but I just put a comment there that I'm not sure we actually should play any barks in like a multiplayer situation, so not really using it for anything, but it is there. And we use an RPC to actually play this bark on the client. Calling RPC proxy RPC play bark causes this thing to be executed on the other side of the network. And so here we can then again just call play bark, which calls it here and which gets us here to this to do. So this is where we would then actually play something, whatever we come up with. And so that's the bark manager. This is a completely new system. It doesn't really do anything else. It just handles the network communication for us. I think the first thing that we should probably do is just print that we've actually gotten here. So playing bark for character. Like so, and then probably gonna want to get the tag names out of these guys. So bark type, and then character. So if we get there, we should be pretty good, because that means, oh, obviously I can compile that because the game is running. If we get here, it's pretty good because we're on the client and we know essentially what to play. But we need to match this with a piece of dialogue and a piece of audio potentially. So that is what this function is then going to do. And then what we can do here is we can send a message, and the message will essentially be the same as what we looked at previously. So we have the in-game UI view model, mission dialog, and maybe we'll want to create a new message type which just doesn't have this mission path here at all, just has these things, and we can do the same thing, push dialog line. So some kind of bark message. That should be good. Okay, but let's make sure that we get here first. So play bark, I don't think this is called anywhere. Well, it's called inside the RPC stuff, obviously, but nowhere else, no. So that was the bark manager. We also have the com radio manager. And this has a slightly more specific thing, play radio bark. Yeah. And here we can quite simply, we are asserting here that we're not on the client, so we are on the server. That looks good. So what we can do here quite simply is do means dot bark manager server pointer and play bark. We have the character and we have the bark right there. So bark type comes in, character is figured out based on the contact ID. Yeah, that looks good. That looks good. And I have a comment here from earlier, but we don't actually want to do an RPC to the client here because the bark manager is the thing that actually does that. Right. So let's just make sure that we get that printf thing. And actually I can make a small change here to launch, do the play level command line parameter, and we'll go straight into the game. So printfs are appearing here, and if again we load the test vehicles, this one doesn't have any radio set up, so it just shows no contacts within range. This one actually does have it. Scout in shed. So if I do move here, playing bark, com radio message, accept movement for character narrator. Oh, I missed a space there. And you can see the greeting there as well. And there you can see the guy eagerly driving to our position. And let's see what it does. Probably just makes a sharp turn and then, yeah. The actual movement is kind of a little bit rough still, as you can see. But yes, we do get the printfs there, so that's good. That would be good, something like that. I'll just comment that out, but leave it in for now. Right, so what do we want to do now then? Essentially we have like a bark type here. We essentially want sort of like a database of barks. Right. We want the database of barks because, like, if you start with just this greeting, then this greeting can map to a whole bunch of different barks. I'm gonna add a new file here that I call barks.zig, and let's get this stuff here. Not sure if we need some of these. We can leave them in for now. I think I will move this bark type to there. Like this, and then we can go to means. Means, if you don't know, is sort of like the code name for the game, so it's just used in the code all over the place. And yeah, we have bark manager, Probably put it before that. Barks. Import gameplay barks. We have the barks here. Bark, 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 bark. Bark manager. Maybe we want to put it here as well. So Zig is obviously a little interesting in the sense that it doesn't really give you any compile errors for code that isn't actually used. But you can do this sort of force analysis thing here, where you're like use the step testing, reference all declarations recursive to figure out everything. That's why I have a list of things here that I wanted to actually analyze. Right. So now, of course, play bark. This needs to be fully specified. So it would be means that barks.bark type, like so. That should be good. That should be good, but I think we'll probably have one more problem. Yes, com radio manager needs the same thing. Like that. One more. Okay, why do I actually have it? Bark type, bark type, bark type. Okay, yeah. Yeah, that's a component and that's the manager. Okay, that's fine. That's fine. So this now builds. That's good. So if you have a look at all of the things that we need to sort of specify, all of the things that we need to have at hand when we want to actually show one of these barks, play them back, go to UI, in-game UI view model. So basically all of these things. Right. And this is actually kind of interesting because the audio is optional. We don't need to have the audio play yet. We can just give it an empty string and it will skip it. Text is localized, or is text localized. If we put this to false, then we can quite simply just give the raw text here that we want the person to say. So that's also kind of handy because we don't need to mess around with any data. We can just do this all in code, at least as a first version. So let's copy these things and put them in the bark manager, just as a sort of reminder to ourselves that, okay, we need to figure out all of this. And I think we'll go and hook up that new message now, because that then should give us the opportunity to start showing these things immediately, even if you don't have any sort of sensible thing to actually say yet. So let's see, it needs to go into some category. Game logic messages. Maybe that is a good one. We do have HUD messages here, and it kind of technically goes to the HUD. So maybe that could be another one. Let's put it here. So play bark. Quite simply. I think that's everything we need, and then we just need to register it. So do this. Play bark. and HUD. And of course, this in-game UI view model should already subscribe to the HUD category, because that is sort of right up its sleeve, right in its wheelhouse. So here we can quite simply copy this. We do play bark instead, and all of that goes away. I think I'll just take whatever we had here in the mission dialog, except for this mission path, which we won't have. Like so. So now if we play this, or if we send this play bark message and we give all of these things, regardless if they are empty or not, then we should get things on the screen. And so that's nice. So let's try that. Let's see. Bark Manager. See if I can remember how this works. So we have message params. This will be self message node alloc message params. Add a bool. Oh, add int then, I guess. Wasn't it bool? It's actually given. Oh, it's given as a uint. All right. Okay. Maybe I didn't have Boolean parameters. Haven't really done a lot of message passing lately. So I guess we can do like 0. I'll put it false for now. Actually, let's do it like this. Const is text localized. Const text. Const audio. Character path hash. Oh, that's a number. Const duration. I want to actually specify the types for some of these, otherwise it will get confused. So that's supposed to be U32. And now we can just do if text localized 1, else 0. And we don't need this. Add string text. And another one, audio. Add uint. Params float. And then we do self message node send message with params. This would be means game messages, game message play bark, and parameters is message params. Let's see if that builds. We need that one to build. Now this won't make any sense, because first of all we don't have any character set and the text is also empty, so let's make something happen here. I think we can do means dot is it world get character Nemo path, and we have the character, but that returns a string, which means that we need to hash it. So we can do basis string make string hash. Maybe we could make that be compile time later on. Okay, bark type. Let's make it so that we can actually see what's going on. So does that work? Is this fine? I think that should be fine. It essentially sort of tells you. It says the type of bark that it gives you. It shows it for 3 seconds. Let's see if that works. Right. Right. Com radio greeting. Haha. Com radio message accept movement. Isn't that cool? Isn't that cool? And now if we open the gate, we can already start opening the gate over here because it's kind of slow to open. And now we can start closing it again. All right. So now if you tell it to, it says greeting, and then it says refuse. I refuse because I don't know how to get to you. Open the main gate, greeting, and accept. So you can see that the HUD it really is a queue, even though I kind of gave that order or sent that message quite quickly to it. It does play them one after another with their full duration. And yeah, that guy should be heading over here, but I bet he's actually stuck here somewhere because yeah, they don't do reverse turns yet, as you can see. So, oh, you're so stupid. You're so stupid. Let's make that ourselves. Something like this. And now if we try again, now it should have an easier time actually making it happen. Move here. I accept the movement. Okay. So that works. That's nice. Now then, based on these two parameters, we should somehow select a sensible thing to show and or play. And how do we do that? Let's go have a look at this message queue one more time. Right, so the duration essentially, let's see, time left to live. I bet that is calculated based on the duration. Yes, it is. Push dialog line, duration is time left to live. It's a float, it's initialized, it's stored, and here we just subtract from that, and if we go below 0, then we hide the message. We don't actually stop the audio. Now that has to do with the and forget right there in the audio playing name. So essentially this play by path and forget 2D, which means that if we give it like a longer audio event, we give it like a 2-second audio event, and then we give the duration as 1 second, and then we have a bunch of lines. They would sort of play on top of each other. That's probably okay. That should, in theory, never happen, but we can at least like play with it a little bit to see that what it would look like if we actually had sort of like a database of these things going on. So what we should perhaps have here is some sort of struct type which contains all of this, right? Or maybe all of that. Not the same thing, but maybe easier to work with this way. Let's copy it here. comment it out and do like a pub const bark data. And these are essentially just containers for all of this stuff that we want to have. So like a bool, false. So I wonder if we can actually just keep all of the texts and all of the audio as string literals. So the text will most likely be like a localization ID later on, when we actually have proper text and we start to localize them. I have some localized stuff already in the game, and the system that I use to actually manage those, they generate this kind of localization key. Enum. We looked at one of those audio files earlier for some of the AI generated dialogue. There's like 5 lines of dialogue basically, and they each have their key like this. So I bet this is actually kind of what we want here. Instead of having the actual text there, we want to have these, but you can also give them as strings, which is kind of handy. So, and of course these are string literals. Basically what I mean by this is that we might be able to just have this as a const UH slice, which we initialize to an empty, right? And we have audio as the same thing, also an empty. Like that. And now we can have essentially like a hard-coded list of these kinds of things. But I'm a little bit unsure of what the optimal format would be to sort of manage these guys. Because if you if you ask the system to play like a greeting bark for a given character, you have the bark type is greeting, the character ID is, well, something that we eventually can then turn into one of these path hashes. But we can have several of those greetings for that character. So essentially what I'm trying to say here is that we have these two values, and they map to not one, or at least not necessarily one line of dialogue, but several. So what would be the optimal way to actually keep these kinds of things in memory? Does the standard library have some good? Even I have some just raw arrays here. I guess that might be a way to keep things going. So here we have a localization item. Also has a small struct. This is the thing we just looked at, and this is of course one way to have it. But here we have each of these is unique, and we can quite simply find them by either the hash or the text there. Yeah, I didn't really think this through. Not that it's super important right now how to actually do this, but it would be kind of nice to get it stored in a sensible way from the very start. I'm just looking to see here if there's any sort of hard-coded amounts of a lot of data around. And there might not be. Okay, well, that doesn't really matter all that much. I think what I will do for now is quite simply add a function here. Let's do pub fn get bark data, and what this will want is the character and the bark type, but probably also a random function generator, right? So that we can, yeah, not that one, but math in basis, math.zig, right here. So here I have like a pseudo random number generator. I think we can just pass that init new prng. How was this usually just like passed around? All right, it's passed around as an std random, right? And then basically we can create one of these PRNGs, and we call random on that, and that gives us the random number generator. And that's nice because then we can do, essentially, we can do this. We can do, this is minigame logic component. All right, I'm just going to move this off to the side for now. We can add one of these things to the bark manager. So RNG, PRNG, like this. We need to initialize this somehow. Like so. And I think that's it, basically, yeah. Yeah. So what we want to give here is random. We want to give character, that was means world character ID, and then bark type, and that's a bark type. And this should give us probably like an optional bark data, and actually probably an optional pointer to a bark data. Maybe even a const pointer to a bark, optional const pointer to a bark data, right? Because maybe there is a combination of character and bark type, which we just don't have any line for, and the game shouldn't crash if that is the case. It should just like not do anything. And so here, let's see, bark manager, we can go here and go if means.barks.getBarkData. This would then be self RNG random, and this would be character, and that would be bark type. And then we might get a bark data out of it. Alright. Copy or comment those out. Move the whole thing in here. Bark data. Do I need to do something like this? Bark data is, alright, it's probably, yeah, I don't need to do that, but I need to type it correctly. That is what I need to do. Like so. I think that's probably fine. And now, of course, we don't get anything because we're returning a null all the time. And so basically, depending on how we actually store this database of barks, maybe it's even loaded from a data file eventually or something. But depending on how it's stored, this bark data will work out one of those pieces of data for us and return it. However, for now, I am just simply going to return something hard-coded here. So let's see. We can switch on the bark type. I don't know why it's not giving it to me. So greeting. That's, you know, something. I have the generic accept, which we don't actually ever send currently. We don't bark that ever. We have the movement once. So do like return bark data. It's localized false. Text something. Audio is something. Character path hash is something. And duration is, let's say, 3 for now. Right. So this guy, this random thingy, what does this give us? Int range at most, int init, probably like a range at most, at least at most. Okay. Maybe we can just work with floats. I assume this thing would return a float between 0 and 1. That is like typically how these things work. Float, yeah. So this is like 0, but excluding 1, I guess. Okay. So we can just do something. This is not how I'm going to do this eventually, but just to have something right now. So we'll do like a const r. Yeah, r is random float f32, I guess. Yeah, and so if r, then we do like what's up, else hi there. Audio is nothing. Character path hash, we can just do const char is do the same thing we did previously. String, make string hash means word get character Nemo path and characters. A whole bunch of converting from one form to another. Just use it there for each one. Right, that's that. And then we can do movement except, and we can do it's quite simply do something similar. We can do on my way or be right there. And then refusal is like don't know how to get there. And the other one is like what should we do? I cannot find a path to you. Something along those lines. Right, it wants actually a pointer. Well, we can quite happily return it by value, because all of this is like quite small. These are essentially just slices, or they are slices, and these are very small, so it's fine. We can just return it by value, and then that will handle it for us. Maybe later I'll use actual pointers if I feel like it, but yeah, that should be fine as well. But that will require me to actually keep those things alive, so just doing it as an optional by value for now is quite fine. Okay, let's see if this works. So, load test vehicles, switch to this, and now we can do scout in shed. Hi there. Move here. On my way. Hi there. Hi there. What's up? Yeah, the three second greeting is way too long. Not that it really matters, but I'm just gonna make it shorter. Let's make it 1 second. And it's a little bit annoying that the menu makes that the radio chirp when you open and close it, but actually not when you give an order or you send a message to one of these guys. But of course that is because I expect the actual bark to contain that. What's up? Hi there. What's up? What's up? Hi there. Yeah, so you can go sort of back and forth between those different states of the menu and just have it greet you. Be right there. Oh. Such a bad driver. Oh, they missed their target apparently. Let's debug the thing. Where is it trying to go? It's trying to go there, but apparently the turning radius is a bit tight, or a bit large. It would need a tighter turning radius, which basically means that it would need to slow down, but it currently doesn't know how to do that. Yeah, move here instead. On my way. Oh, I forgot that test vehicles actually spawn in one of those guys there as well. Oh well. Hi there. Be right there. So yeah, this is nice. This already gives us a much better idea of what they're thinking. We might want to, if on the way they actually run into some issues and they can't actually get to where you wanted them to actually come, then we might want to have them bark something along the lines of, "Oh, I was on my way there, but now I don't know where I am and where you are," or something. "I got stuck. Help me, please." That could be a nice bark too. Just drove right through the front gate to open the gate and see if they get unstuck. And right into us. Alright, so this works. Now then, what we could do, of course, is to actually put in some lines there, put in some actual audio. And have it sort of figure out the duration and all of that based on the audio. Wouldn't that be interesting? Would that be interesting to watch? Let me know in the comments. If we do that, then we can do things like this, because like the duration and the audio, of course, depend on which one we actually end up choosing. Yeah. I'm gonna have a quick look at my notes here. Yeah, I think I've done pretty much all that I set out to do. Except perhaps figure out a good way to store these things. One thing that we could do is have have a hash map, right? And the hash map, the key, the hash map is essentially sort of like a combination of these two things. and then when you figure out the key, you either you find something or you don't. If you don't, then you just return null here. If you find something, then you get essentially what you find there in the value is a list. And so there can be essentially like different numbers of barks available for different combinations of these two. That could be kind of interesting. The thing is though, how maintainable is that if I have like hundreds of these barks in the end? Not necessarily very maintainable, or at least not very fun to work with. I do wonder if I actually should like generate these things, generate like this like a hard-coded list, or then quite simply have them in a data file. Maybe the data file is actually something to look at later on. Yeah. So what would that look like if we have like a bark database? I typically call this G for like global. I know this is not really global in Zig because these modules are, we can like instantiate modules and all of that. So it's not really global data, but still that's sort of how I currently name these things that are sitting in sort of like data that is sitting in directly in the module, the Zig file. So that would be like a hash map of a type. And what would that type be? So this is a U32, and I think this is also a U32. Yeah. So we could just smash them together and create a U64, right? Something like that. And yeah, I don't think we need to give those context and max load percentages. Just need to give it a value, something like that, right? Undefined. That makes sense. So previously I had something called the crane cable magnet assembly. I did a bunch of messing around with bits here. So let's see, write packed int std stud mem check one thing quickly here on the side. Yeah. Right. How does like bit shifting actually behave in C with regards to this? Is it the same as in C++? So this is like a U32 and that's a U32. Yeah. It does look kind of similar. So we could do something like that, right? Barks. So this could be like int from enum character, and this could be int from enum bark type, and that would give us a key. Key U64. Something along those lines. Yeah. I don't know, maybe. Let's put in a function here, init database. We basically need an allocator. Right. I can probably return errors. Something like this. Allocator. And then this is where we would actually start filling in those values. All right. I think so. Let's put a function here. Make key. This would be character. And this would be bark. And it returns a U64. And it's basically just this. Bark type, yeah, that's fine. Right. And then we need to initialize this from somewhere. We can do that from the app. So here, for example, we do means.barks.init database self-allocator barks init database. Maybe there's a more efficient way to actually, since this thing probably will be initialized at startup and doesn't necessarily change, might be a more efficient way to actually get things out of it. But I guess a hash map will be will be quite all right for now. So this is where we will now probably load this from like a data file. Well, let's just hardcode things in for now. So let's put a. Actually, yeah, this is just a slice. We need to store them somewhere, huh? Where do we store them? Where do we store these things? Do we actually make this like this value be an array list? And then we use like an arena or something to keep all of these. We don't even need to do an arena because we can just deinitialize everything there. Yep, haven't really thought this through. Also, that means that we would need to store these somewhere, right? Because this is just a reference, so this works with literals. It doesn't work with things that are loaded from a data file. Well, anyway, we won't load anything from a data file today, so it might be just completely fine. So what we could in theory do here, something like this, where we do like let's see, we do narrator greetings, and this is bark data slice, right? And we have, you know, a few of these guys here, something like that. And this would be just like, yeah, that's what's up. Right, can I actually run this at compile time? Maybe I can. Let's see if that actually works. So this would be just narrator. These would all be narrator. It's high there. Yes. Hello. I don't know, just to come up with something. And it's formatting is a bit wonky. Is that really how it wants it? Okay, apparently it is. Right, and then we get the key. So we do make key with. Oh no, actually not there. Sorry, not there. Here is where we will actually do all of that. So we do key, make key, character, bark type, if bark database get. Is it called just get, maybe? I think so. Get key. Then we get the slice out of that, right? Then the slice is a slice of bark datas. And this is now where we can do. And maybe we want to get an index out of this now. So int at least at most. So probably like u size at least 0, at most entries.len, and that would be index, and then we return entries I. Right? Like the retrieval is kind of nice now. It's kind of short and concise, all of that. Just this actual storage and like inserting that is a bit painful. So we would do like gbark database. Is it init? No, it's not. Is it put? Yeah, put is what it is. So we can do like dot narrator, and we can do dot greeting, and then we give it that. And that needs to be a try. Error is ignored. Right, try. It's supposed to be auto hash map. Yeah, and we need to auto hash map it here as well. Mark data does not support array initialization syntax. Huh. Yeah, it needs to be right. It needs to use this syntax here. So right. Is it like this maybe? Yep. It just wants the address of that. Yeah. Be right there, and then like refuse movement would be like how can do nope or whatever, something like that. So we can have like different. This could even be just like one. Accept movement, refuse movement, accept like that. Yeah, it's not a super nice way to actually do this, but I can sort of see this being kind of nasty to maintain over time. But yeah, I mean, I guess it works. Yes, hello. What's up? Hi there. Oh no. What happened? All right. Yeah, I've got a -1 there. Indeed. So it needs to be this, obviously. Yeah. So we can just keep toggling this and we'll get a whole bunch of greetings. And I guess what would make this even nicer is if we made it so that it doesn't repeat. So you never get like hi there and then hi there again. And that should be really easy to do, actually. At least if we don't care about how elegantly we make it, we quite simply do. Yeah, that's a U size. So we just do last RNG value U size equals 0. And then we do right. While does Zig have a do while? I don't think it does. Just have a do while loop. Yeah, like I don't think that works. That's annoying. Okay. That works, but we do that int range at most. Twice. That's a little bit annoying. But actually, what we want to do here is like if entries.len is larger than 1, only then do we actually want to have it sort of have it set there. Otherwise we might get an infinite loop if you have just one and then it just keeps requesting the first one again and again. Let's add a comment here to like prevent the same park from appearing multiple times in a row if possible. And this one we don't need at all. That was the old stuff. All right. test vehicles. And then we just go here and we start spamming. So now you can see that we get a different bark every time. I mean, we only have 3, so. So not that interesting. Somebody does like, hi there. Yes, hello. Hi there. What's up? Hi there. What's up? Hi there. Yes, hello. Yeah, it does get a little repetitive if you just spam it, but yeah. Right, so I'm pretty happy with this this interface to this. Calling get bark data, and you might get a bark data out, or not, if there is no such thing for that combination of values. But I need to think about how I actually want to store these. That wasn't really sort of the main thing for today's stream. But yeah, maybe this is enough for today. We've been going almost 2 hours. So, thanks to everyone who showed up. I hope you found this interesting. If you did, then why not actually subscribing and liking the video to make sure that it is visible to more people. With that, I thank you for your time. I hope you have a good weekend. Hope to see you in the next stream or video. And